Hello and welcome back to the shop. And today we're going to be working on my bandsaw again, my horizontal bandsaw. And some of you may know it's a little Harbor Freight 4x6, 7x4 inch horizontal bandsaw. Now, Harbor Freight, not the greatest thing in the world. These bandsaws are actually pretty good. You do have to do some tweaking to them, so you know what you're stepping into. You're going to have to do a lot of adjustments on it, get a good blade for it. But for the cost, I mean, with a coupon, I think you're running around 160 bucks, somewhere around there. Well worth the money and the time. You can buy them out of, they must all be made in the same factory because they all look exactly the same, except for maybe the paint job and some, and the placement of the on and off switch, and some of them have American-made motors. But Enco sells a version of this, MSC sells a version of this under the wrong Fu name. They all look the same. So Harbor Freight's obviously your entry model, cheapest to the line, but they work. And the biggest downfall with them, besides just a little tweaking that you have to do, is the spring downfeed. It just sucks, and I'll show you why and how it works. It just so happens that last week I was walking through Barnes & Noble. I had some time to kill at work, so I decided to grab a magazine, sit in the truck, have a coffee, read a magazine. And I browsed up to the magazine rack, and lo and behold, what did I find there? But this month's Machinist Workshop, this is volume 28, number 5, and we have an article of putting a hydraulic cylinder for the downfeed for that version of the saw. This is not a Harbor Freight one in this article. This is a, it was a wrong Fu brand, but as you can see, it looks almost exactly the same. So we're going to do that with just some slight changes in measurements to specifically match my machine. Your machines may differ, and I can almost guarantee you that even between one Harbor Freight machine from the other, there's going to be some slight variations. The overall premise is basically the same. I suggest you go out and get this magazine if you want to do the project. That way you have a written article right in front of you. And it works pretty good. And he does the same thing in here, and it's generic dimensions. And like I said, we're going to fiddle around with them. So I'm going to show you the downfeed over here and kind of show you the concept behind the cylinder real quick on the table and some of the basic components, and we can jump right into the machining. Okay, so this is my machine right here with some modifications. And the biggest issue is just this spring downfeed. And all it is spring and tension. So I got it tensioned up pretty good right now. It's got some tension on it, and you can see, you know, if I tip the head over, let me actually zoom me out a little bit better. Maybe to that position there. I can tip the head over. All right, I'm letting go of the unit right there, and it's holding. And I'm gonna tip it down till it overcomes the spring pressure. And you can see it goes slow and it speeds right up as it goes down. So, I mean, you have a little bit of downfeed control with it, but it's nowhere near the fine speed you're going to be able to just let it set a speed and go straight down. So, you know, obviously as it gets past its pivot point there and gravity takes over, it's going to be putting more and more pressure on there. And it is really hard to gauge what you're putting on your workpiece. So with this hydraulic cylinder, it's going to replace this whole tension mechanism with a little hydraulic cylinder and an actuator rod that's going to bolt up to the same position, and we'll be able to have fine downfeed control with a needle valve. Alright, so let's go over to the bench real quick and just show you the premise of how this cylinder is going to work and why we're doing it this way. Okay, so here's the basic design of the cylinder. These end caps here are going to be made from square stock, 2-inch square stock. This inner tube here is going to be made out of 1.5 inch OD. This is a drain tailpiece for a sink. And then here's our needle valve, and here's just a compression 90 with a connector rod. Our piston can be, which is right here, can be made out of anything. It can be made out of brass, aluminum, steel. We'll probably go with aluminum. And like I said, our end caps are 2-inch aluminum square, and our shaft here is a 1/2-inch drill rod. And then we'll also have 4 of the threaded rods to bolt those caps together there. Now, basically what's going to happen is when we want to perform a cut and we want to feed the saw blade down, what's going to happen is we'll adjust this needle valve, and that'll allow fluid to be compressed this way out. It'll flow up through the needle valve slowly at a consistent rate and back into the other side of the cylinder, allowing the cylinder to slowly drop. When we want to raise the head, instead of having to mess with this valve, what we have here is basically a steel ball and a spring, effectively making a one-way valve through the entire piston. So when we pull up, it's going to allow the fluid to go right through that check valve and into the other side so we can raise it. This piston will be sealed with an O-ring. These end caps will be sealed with an O-ring on the outside and on the shaft. Now there's a problem with this design, and the problem is this shaft only goes through one side of the cylinder. So as this gets compressed, there's more volume of fluid in here than you'll be able to fit in this side, because it's being some of this volume is being taken up by this rod. So with this design, you would need some sort of overflow tank. You would need a place for that extra fluid to go and collect. In the case of something like an excavator or a piece of hydraulic equipment like that, you don't have that issue because you already have an open tank, it's closed system, but you already have a giant reservoir. So the way to overcome that is we're going to take this shaft and we're going to extend it out the other side. Now the volume of this side is 100% equal to the volume of this side. So the fluid always has a place to go, and it doesn't need to pool somewhere because we're moving the exact same amount of fluid from this side to this side. And that's basically how this system is going to work. So I went and picked up all the components. Here's the needle valves and compression fittings, 3/16 threaded rod for the bars, 1/2-inch drill rod for the rod, tailpiece for the cylinder, got an O-ring assortment, and I also picked up, this is actually a 3-foot piece of 2-inch aluminum square. I went by Metal Supermarket in Woburn, and they actually had this in stock, and so they cut me off a piece, and we're good to go. So we're gonna go to the saw, and we're gonna cut ourselves off 2 chunks of this, and we can set it up in the 4-jaw chuck to face and bore to fit this. And we're also gonna have to grind a tool bit to be able to make 2 O-ring grooves in this, one in the bore for the shaft and another one to fit the OD of this. So let's get started with that. Alright, so we're just going to cut off a chunk of this bar a little over 1.5 inches long so we have enough room to face both ends, and we can just face the ends down to equal 1.5 inches when we get it in the chuck. Now, here's another problem with this spring mechanism on the side here. With an actual cylinder and piston arrangement, we can actually set this at whatever height we want, close the needle valve, let go, and it'll stay there, which would let us bring this down to the stock and move our stock in and out in reference to the blade to get our length. So with the spring arrangement, it's kind of a pain in the butt, and I do have this unplugged so I don't end up cutting myself, but you kind of gotta hold it and let it rest against your stomach, and then especially if you have a long piece of stock like this that's heavy, it's going to want to tip, so you have to reach out with one hand to hold it, stick the other one in here, and kind of guide this up against the blade without having the blade touch the saw. You know, hold it in place and then crank it again and double check your stuff. So you basically need an extra set of hands. And you know, I don't live next to Chernobyl, so I don't have one of those. So there's our 1.5 inches there, a little over 1.5 inches, so we can face, and we're gonna plug this in right now and then cut it.
just going to let that go about its business and come back when it's cut off. Okay, so I already made one end to be able to test my O-ring grooving tool that I made and just my technique, and it came out okay. There's some chatter in the bottom one of these grooves, but I think we overcame that with some modifications to the tool, and it came out relatively good. The only thing I don't like about this, which I mean, I went by the standards, I went by the numbers called out on the sheet, and I'll show you all this. We'll go through all this, but that O-ring groove looks a little wide to me, but it could just be me because I've never really worked with all this stuff before. And there's another O-ring groove in the little 1/2-inch bore in there. And I set this up with a piece of that rod in here and the tube in place and some water, and it held the water overnight, didn't leak out. So there is a seal, I just don't know how it'll act under pressure. So if for any reason this doesn't work, we'll just have to make another end cap, but we'll make a few changes to the way we do this one. And you can see we have our rough sawn block here, and I just deburred all the edges. And this chuck here is set up relatively square right now just because I had machined that block. So we're going to mess it up here purposely to show you how to indicate a piece of square stock in. So what we want to do when we tighten this down, since we have a saw cut face on this side and it definitely is skewed, we don't want to jam that right up against the back plate of the chuck here. We want it proud a little bit so when the jaws clamp it'll kind of straighten itself out. Then we can face the front side, flip it around and put that nicely faced piece right into the back of the chuck, and then face this side. That way we have two perfectly perpendicular, parallel surfaces. So right now we're just going to hold this off and we're going to, you know, eyeball this in between the lines, this square stock here. And you can get pretty close by eye. And we're just snugged in there, and you can see we're not actually touching, well, we're touching that one point of the back plate of the chuck. So we'll just nudge that forward just a hair. So now we're not touching anywhere. Just give these a little snug. Okay, get our indicator in place and level the jaws so they're parallel with your table, or relatively, it doesn't have to be perfect. And take your indicator and just eyeball center of the stock. Again, doesn't have to be perfect. So around there, looks pretty good. Make sure that we're not hitting the jaws. Alright, now rotate your chuck and you'll see the number. Just make sure you can see everything in the camera. You might get a little bit of glare on this. Let me see if I can kind of overcome that. Not really. Oh, I'll try to stand here, maybe that'll help a little bit. But you can see the needle move, it'll stop and then go back the other way. So we're at the point that it stops and starts to go back the other way. Set 0, go over to the opposite jaw and do the same thing. So now you can see we're minus, or let me see if we are minus. Yep, we're minus. This has to come towards me. I'm just looking at these concentric rings because doing it this way you can kind of screw yourself up if you're off by 100 thousandths. You could think you have to go the other way when you don't. But this is, we're minus about 46. So basically what we're going to do is we are going to work our chuck jaws and half that reading towards me. Okay, then we're going to go to the next jaw and do the same thing. Okay, so we stop right there, so we're going to 0 our indicator, opposite jaw. And that's where, right where that's our lowest point, we start to back off. And I'm just checking my stock, and yep, it has to come towards me. That's 31, so we're gonna go 15.5. And we're gonna, again, have that reading. To about 15.5. Okay. Now, since we did all 4 sides, we're gonna set 0 and go to our next jaw, and we should be pretty close to 0. Alright, you see we're a little off. And we're about 5 off, so we're still off. So we're gonna start doing that again. So we're there, other jaw. Let's see, we're -2, so we're gonna have that reading. Should be able to just tighten this jaw a little bit to get it to 1. Go to our next jaw here. We're right at 0. Go over to the opposite jaw. See where we are. And -1. We can take that half out. Alright, so that's pretty good. Now we'll see where we are. Alright, so set 0. We're at 0 on that one. We're at 0 on that face. This is -1 on that face. And we're at 0 on that face. So on one of these sides there's a thousandths difference in it. Not a huge thing. So we're going to call that nice and square, and we're going to face the front here. Alright, I got the little spot off the camera there, so we're just going to deburr this with one of these little guys, and we're going to flip it around in the chuck, put this face flat up against it, re-indicate it, and I'm going to face off the front again. We'll skip that because you just saw it. Okay, so now what we need to do is put a 1/2 inch hole in the middle straight through the block, and we want it a little oversized because it's going to be fitting our piston rod. So whatever you use for a rod, whatever diameter, give it about 1,000th of clearance or so. And I just happen to have a there it is. I happen to have a reamer here that will allow me to do that. That will give me about 1,000th of clearance on that rod, in combination with the size of the rod and the size of this reamer. And it works out pretty good. That'll give us a nice sliding surface, a nice true surface to seal against. So that's what we're going to do. Just throw a hole through that. Let me get my drill chuck and I'm going to start going. Now, I know it's only a 1/2 inch hole, but I am going to stuff drill it. Like I said before, this lathe here doesn't particularly like drilling larger diameters if it doesn't have a pilot hole in there. Especially in aluminum, where it tends to get a little grabby, not necessarily grabby, but it tends to bind a bit. This lathe definitely needs a clearance hole through this. So first up is spotting drill. Next up will be a 5/16 drill, and then we'll go through with a 31 64ths and then our rimmer. Okay, so for our reamer, I'm going to slow our lathe down a little bit. And we're actually going to keep it at that spot on the pulley. We'll just throw it in back gear. And give her a ream. You see we're not removing much material. We're just making that hole nice and true into a consistent size. Alright, we're through. You can see there on these flutes, that's the amount of material that we removed. Not much. Okay, so that's all set in there. Now what we need to do is open up a bore to fit our tube, and this is an 1.5 inch tube, and we want about 1,000 clearance on this or so, 1 to 2 thousandths, and we want that bore to be a 1/2 inch deep. So you can use an indicator on your carriage. You can use a carriage stop, or anything that you can to be able to measure your depth in. We just want that 1/2 inch. So let me get my boring bar in place, and I'll get everything zeroed, and we'll stop boring. Alright, so this is the tool we're going to be using here, and it's just high-speed steel. And you can see we have, from here to this edge, we have clearance. And also the tip, you can see the way that's cut, so that all we're cutting on is that front edge. And that'll also allow us, since we have clearance on this side, we're going to go in and open this up to our diameter, but we're going to leave it 10 thousandths shy on the bottom. So when we get our last cut, what we can do is just come in and then go in that last 10 thousandths and then face back to the center, and that clearance will allow us to cut on this edge and clean up the bottom and get a nice smooth surface on it. So what I'm going to do, we'll put this in so we're set on center height and all that good stuff, and all I'm going to do is come here and just rest the tool against that face. Not ridiculously critical. The depth, we just want it pretty close to 1/2 inch. I mean, if you're off by a couple of thousandths, ain't going to kill you. This here, I'm just setting an indicator on my carriage. This is only a 1 inch travel indicator. I had a 2 inch on here, but when I was cleaning my lathe and I took the one I had on here off to clean it, I actually dropped it and broke it. And luckily it was just one of those little cheap MSC brand ones, so I'm not too sad over the loss, but it helped out a hell of a lot, so I didn't have to keep moving it around the carriage as much. But alright, so we'll kick this back up to speed. Taking out a back gear here. And we'll probably go maybe 100 thousandths at a time. I think it can handle that. And we'll stop boring this. So it's going to come in. I'm going to touch. That was a bad touch. Come in. There's that touch. I'm going to set 0. And our dial here. Back out 100 thousandths. So that's 50 thousandths per side. Engage our feed. And I'm feeding in at about 5,000 per revolution. See how it handles. And 490,000 deep. Should give me about 2 or 3 thousandths clearance. And we are at 1 inch 503. So get my tube. And a nice snug fit in there. Nice fit. Alright, so now what we need to do is come in with our tool. Alright, I'm at my setting, my depth setting. Now we got to feed in our 10 thousandths. I'll walk it down and then I'm going to feed out. And you can see that cleared up the bottom of our bore. Alright, so for our O-rings we need to know what size width the groove needs to be and what size depth needs to be. Now you can go to any kind of O-ring manufacturer and print out a sheet like this, and this will tell you everything. There's all different kinds of seals, so we have 2 different kinds here. We have a radial static seal, which will be on the tube to the block, meaning that that tube isn't going to move. That's a static seal. And we're also going to have a reciprocating seal, reciprocating radial seal, meaning we're actually going to have 2 of those. One of those is going to be on the piston rod, and one of those is going to be on the piston itself. So 2 different types of seals means 2 different types of grooves. Your O-rings are sized by numbers, which are right here. These are all the numbers of the O-rings, and these are the cross sections. So that's basically the thickness of the O-ring. So the one that we're going to be using for the tube seal would be this one right here. We're going to use I believe it was a 211. And so gland depth, so we need a depth, excuse me, we need a depth of 111 thousandths to 113 thousandths is the actual depth that we need, okay, for the groove depth. And the gland width right here, what we need for it has no backup, and we need 187 to 192 thousandths width. And for the seal on the shaft, we're going to be using a smaller O-ring, so we need a depth of 88 to 90 thousandths, and we need a width of 140 to 145 thousandths. So that's how we're going to size. That's how we size everything. So, and the tool that I'm going to use for it. Now I had a bunch of these, and these are for like snap rings and things like that. But the depth of it, of the tip of the tool, is too small. I don't have the depth to be able to plunge in the distance I need, and these are carbide faces. I can't grind them. So I made up my own. And all this is, started out as a piece of 1/8 inch high-speed steel for a boring bar, and I just brazed it to a piece of steel, silver soldered it right to the end, and then ground it to width, made sure that this face here was parallel with this face, and ground some relief into it. And it works pretty good, and that's what we're going to be using for our grooving tool. Now the width of this is not, I think it's around 135 thousandths, so we're going to have to come in, groove, and then step over and step back. We're going to have to widen that groove, but it works pretty good. I've already tested it out. You can see it there. Okay, I just came in and touched the tool to this front face and zeroed my indicator on my carriage. So what we're going to do now is come in half the distance of half the width of the cutter, which is 67.5, 65, 67.5, right about there. I'm going to zero the indicator again. We're going to come in 250 thousandths, which would give us right in the center of that bore. So 250 thousandths, and that's where we're going to make our cut. Now, once I make that cut, I'm going to have to go over to this way, go inside 26 thousandths, and back that way 26 thousandths. So what I'm going to do is right where it is now, we're going to zero the indicator. Okay. Now I'm going to get a my actual dial indicator on my Noga, and we're going to put it up here so I can directly measure my depth instead of using my hand wheels. So I'm going to lock our carriage down in that position there, and take the Noga, making sure we still have enough room to move everything, and we're going to finagle this here to touch, and I'm just riding it right along this tool post right here. So we'll do this one and like this, and then when we do the other one, we'll go through the process from above. So we're going to slow this lathe down, because this lathe does not like internal grooving, especially with a tool this small. Okay, so our depth, let me double check my depth. Is 139 thousandths. Alright, let's give this the old college try and see if my modifications of this tool got all chatter out of it. So I'm going to come in until we touch. Alright, there's our touch. I'm going to zero my indicator on my tool post, and we're going to come in 130 thousandths. And we're just gonna go slow. Alright, so now we got to do the internal bore, and that's 750 thousandths deep. So what we're going to do is come up and touch again, zero my indicator, crank in here, eyeball the middle, go 1, 2, 3, 4, 5, 6, 7, 150 thousandths. Okay. So now what we're going to do is just back out until we touch, which is right there, and we're going to pop our indicator, and this is a smaller O-ring and a smaller groove, so I don't have to move side to side on this one. I'm going to zero our indicator right there. And we're going to back out 88 thousandths. It's 10. Okay, so we got our block all set, and you can see one O-ring in there, and now if you can see the one in there. And it seals pretty good. It feels really nice and tight on our tube, and it's a sliding fit on our rod. If for any reason it doesn't seal and it does leak, I'm not really worried about this outside static seal. I'm more worried about the inside seal. If that does leak, we have plenty of meat left in here to be able to put another O-ring in another spot from this end if for any reason this does leak, and same with the other one. So there are two blocks, and you can see I have them blue, and we have to make holes for everything. So we have to make 4 holes, 1, 2, 3, 4, and all those are going to be our through holes for a piece of 1024 threaded rod that's going to go through. Now you can, if you really wanted to, make one a through hole and one not a through hole and screw the rod into the aluminum, but I figured I'd just drill straight through the block and we'll sandwich them all together. That just seems like a way easier option than trying to mess with a blind tapped hole in aluminum. Well, on the top here we have to do 2 1/8 inch MPT. One's going to be for a needle valve, on the other one is going to have a 90. And then the other side will have a plug, so we got to drill and tap those for 1/8 inch MPT. And then what we'll do is we'll just drill in from this face in to meet the bore of these, and that's how the fluid will get physically into the cylinder. And then on one block we'll have to drill a through hole straight through, missing the bore, so through this general vicinity here, straight through, and that is going to bolt up to our saw and become our pivot point for the cylinder. Alright, so now I'm just gonna lay all these out, and it's just gonna be caliper dimensions. And yes, I'm scrapping with the caliper, and I know people get all pissy about it, but these are my scrapping calipers, pair of Mitutoyo calipers I picked up off of eBay for I think maybe 10-15 bucks. Cheap but nice set, and I use them for scribing, mainly because the retainer here, for whatever reason, is broken. There's a little plastic retainer clip that's supposed to keep this from turning, and that's broken. But they're still accurate and perfectly fine for scribing. They're nice sharp tips. I'm not worried about breaking them. I'm not worried about dulling them. So I'm just going to lay this out, and we'll start popping all the holes, and then we'll go over to the drill press there, and we'll drill it.